A very pleasant good morning to you all. I welcome you all to the physics online class. My dear students, I hope you are all safe and good in your home. During these pandemic days, you have to stay back in your home and you have to prepare your portions. Okay? And last class we have learnt some basic concept in physics. Have you remember? We learned about some of the physical quantity. Physical quantity can be classified into two types. What and all? Yes, fundamental quantity or basic quantity or derived quantity, isn't it? And also we learned some formula. Then we learned about the distance and displacement and what's the difference between distance and displacement. And today we are going to learn some important definition. It will be useful for your 10th portion. Okay? Please be listen and you have to be learn the daily portion. Okay? First we are going to learn what do you mean by velocity. Now look at this picture here. From the home to the school, the total distance or displacement is 8 kilometers. If you are traveling by a car, we can reach the school by 15 minutes. So we can reach the school within 15 minutes. So here we can define velocity is equal to the displacement by time. So displacement is 8 kilometer, time 15 minutes. So we can define now what is velocity. The rate of change of displacement is called velocity. Rate of change of displacement is called velocity. Or we can define velocity is equal to displacement by time. Velocity is equal to displacement by time. And its unit is meter by second. The SI unit of velocity is meter by second. And this velocity is a vector quantity. It has both magnitude and direction. Okay. It is a vector quantity. So it has both magnitude and direction. Next we are going to learn the related quantity of velocity, that is speed. Okay. The speed is defined as rate of change of distance. Okay. Speed is defined as rate of change of distance. Or we can write distance by time. Okay. Distance by time is called speed. And its unit is meter per second. What is the unit? Meter per second. The speed is a scalar quantity. It has only magnitude. So, velocity we studied, it is a vector quantity, is it? It has both magnitude and direction. But speed is a scalar quantity. Scalar quantity means it has only magnitude, does not represent the direction. So, that is the difference between this velocity and the speed. Okay. Velocity is a vector quantity and the speed is a scalar quantity. Okay. Scalar means it will depend only the magnitude, does not depend the direction. But vector quantity, it will depend both magnitude and direction. Okay. Now look at this example here. The car moving with the speed of 25 meters per second towards north. Okay. So 25 meters is a magnitude and towards north is a direction. So the velocity is a quantity. It has both magnitude and direction. But in the second case, speed. The car moving with a speed of 25 meters per second. Here we are not mentioning about their direction. So it is a scalar quantity. So speed is a scalar quantity and velocity is a vector quantity. Next we are going to learn what do you mean by acceleration. Acceleration is defined as the rate of change of velocity as a function of time. That is, rate means what? Depend upon the time. Okay. Velocity changes depending upon the time is called acceleration. So the rate of change in velocity is called acceleration and the unit is meter per second square. What is the unit? Meter per second square. So rate of change of velocity is called acceleration and the unit is meter per second square. The acceleration is equal to change in velocity by time. Here see the formula. A is equal to, acceleration can be defined the letter A. A is equal to V minus U by T. Okay. Here A be the acceleration, V be the final velocity and U is the initial velocity and T be the time taken. So change in velocity by time, that is final velocity minus initial velocity divided by time, is called acceleration. There is two type of acceleration is there. Now here see this example. When the car is slowing down, the velocity of the car will be decreases. The velocity will be changing. So there is acceleration. The acceleration is negative acceleration. It is also called retardation. Okay. So the acceleration is said to be negative. So it is called as the retardation or negative acceleration. Now in the second picture, the car is speeding up. The velocity increases and there will be changes in the velocity. So the acceleration is said to be positive acceleration. Okay. A positive acceleration means an increase in velocity with time. Negative acceleration means the speed reduces with the time. It is also called retardation or deceleration. If the speed is increasing, the car has positive acceleration, and when the car slows down, the speed is decreases, isn't it? So, it is called as the retardation or negative acceleration. When an object is speeding up, the acceleration is in the same direction as the velocity. Thus, the object has a positive acceleration. Now, you can see the positive and negative acceleration with example. Positive acceleration, example, a bus or a car moving with increasing speed has positive acceleration. We can say that is accelerating with the direction of travel. But what is negative acceleration? In the same example, if the driver applied the brake, the speed of the car or bus, it will be decreases. Then it is said to be negative acceleration. Okay students, now we learned some of the definition, velocity, speed and acceleration, and what do you mean by negative acceleration. Now is a question for you. Noni walks 4 meters per second south. Which of the following best describe Noni's travel? Option A, distance. Option B, time. Option C, speed. Option D, velocity. What is the answer? Can you guess? Yes, velocity is the answer. Okay. Why means velocity describe both magnitude and direction. Okay. So here 4 meter per second. Okay. 4 is the magnitude and the direction. What direction here they given? South, isn't it? So the travels describe what? Velocity. Next we are going to learn what is force. The effect of push or pull is called a force. Okay. So usually we'll say the effect of push or pull that changes or tends to change the state of rest or uniform motion of an object. Sometimes if you are applying the force on an object, it changes its direction or changes the shape of an object. Okay. So if the object is at rest, that state of rest will be changing when we are applying the force. When the object is said to be in motion, if you are applying the force, the motion of an object, it comes to rest. Okay. So this effect is called as the force. And this SI unit is Newton. Force is equal to mass of the object into acceleration. So formula for force, F is equal to M into A. Mass of an object into acceleration of an object. And the SI unit of the force is Newton. Okay. What's the SI unit of force? Newton. But in CGS system, the unit of the force is dynes. Okay. In olden days, people were used the different types of units, isn't it? CGS system, MK system, like the different system they were used. But now only commonly we are using the standardized, international standardized unit. Okay. That is SI unit. Okay. So in CGS system, the unit of the force is dyne. But in SI system, what is the unit of the force? Newton. Now we are going to learn the effects of force. Force is a physical cause that changes or may tends to change the state of rest or the state of motion of an object. See here, a person is pushing a stone. The first stone is at rest. Okay, the stone is at rest, but it moves due to the force applied by a person. Second one, force changes the state of motion of a swing. The force changing the state of motion of a swing. So these are the causes of the effects of force. Now we can see what are the effects of force. See, force is any influence that causes an object undergo a change in speed, a change in direction, a change in shape or size. Okay, it can able to change its speed, it can able to change its direction, and also it can able to change the shape or size. These are the effects of force. Now we can see what are the types of forces. There is two different types, contact force and non-contact force. Contact force means that is a force that is applied by object in contact with each other. Okay, if you are applying the force, it will be contact with each other. Example, muscular force, frictional force. These are the example of the contact force. Okay, contact force acts on a point of direct contact between the two objects. Okay, if you are applying the force, because of the force, the two objects are getting direct contact to each other. That is called as the contact force. Example, muscular force, if you are pushing a stone. Okay, so we are giving a muscular force to the stone, and there is a frictional force between the floor and the stone. Okay, so these are the example of the contact force. Next one is non-contact force. Okay, the force which acts on an object without coming physically in contact with each other is called as the non-contact force. If you are applying the force, or the forces act between the two objects without any physical contact, is called as the non-contact force. Example, gravitational force. Okay, a force acting on two masses. Okay, in between the two masses there is a gravitational force. Okay, if you are throwing any object, it is coming towards the earth, so there will be the gravitational forces there. Okay, without any physical contact, the force is acting, that is non-contact force. Gravitational force we can say, then magnetic force, then electrostatic force. These are the example of non-contact forces. Next we are going to learn a new definition, that is inertia. Okay, this is very important question. What do you mean by inertia? To understand the concept of inertia, just look at this example. If you roll a ball, it will continue rolling unless friction or something else stops it by a force. See, if you are making a ball to roll on a floor, it will be continue rolling unless a friction force between the floor and the ball, there is a friction force there, isn't it? So till that time the friction force is opposing its motion, then only the ball will comes to rest. Otherwise it will be continuously in the state of motion. One more example, if a book is lying on the table, if you are not disturbing, the book is continuously in the same state of rest. Okay, so here see the definition. Inertia, resist change in motion. Object want to stay in rest or motion unless an outside force causes a change. Okay, so if you are applying the unbalanced force, then only the object can able to change its position of rest or change its position of motion. Till that time it will be continuing in the same state of rest or in motion. This is called inertia. Inertia mainly depends upon its mass of an object. Now you can define the inertia, inability of an object to resist any change in the state of rest or uniform motion unless an external unbalanced forces act on it. The inability of an object. See, the object is in rest or in the state of motion. Okay, so it will be continuing in the same state of rest or motion. That is the inability. Okay, till what time it will be like that? When external unbalanced forces act on it. Okay, so this is called inertia. When an object with large mass has a large inertia. when a large mass it is in motion, it is hard for to stop. Okay, so inertia mainly depends upon mass of an object. Now look at this picture here, a stone and a car. Which one have the more inertia, stone or a car? Which one has more inertia? Car will have the more inertia, okay, because comparing with that stone, the car has more mass. So greater the mass of object, greater its inertia. Next we are going to learn the types of inertia. There are basically three types of inertia: inertia of rest, inertia of motion, inertia of direction. Okay, inertia of rest, inertia of motion, inertia of direction. We are going to learn one by one. First type, inertia of rest. The resistance of a body to change its state of rest is called inertia of rest. What's that meaning? One object is at rest means it can be continuously in the form of rest. It cannot able to change the state of rest immediately. Okay, or by itself it cannot able to change it state of rest. That is inertia of rest. Here you can see the picture of the simple activity. That one you can try it in your home also. Just you have to take a glass tumbler. On the glass tumbler, just you have to keep a small cardboard. Okay, a small piece of cardboard, you have to keep it on the tumbler. And at the center of this cardboard, you have to keep one coin. Now what we have to do? Just you have to push the card, otherwise smooth the card immediately. What will happen? Suddenly if you are pushing the card or if you are pulling the card, the coin will falls down into the tumbler. Okay. What's the reason? This is due to inertia of rest, because the coin is at rest. If you suddenly moves that cardboard, the coin cannot able to change it position immediately. That's why it will be falling down in the cup itself. Okay. One more example we can see in our day-to-day life. If you are traveling in a bus, a passenger is standing inside the bus. When the driver suddenly starts the bus, the passenger experiences a backward push. Okay, this is due to inertia of rest. Next one is inertia of motion. How to define inertia of motion? The resistance of a body to change state of motion is called inertia of motion. Okay, the inability of a body to change the state of motion by itself is called inertia of motion. Now we can see the example of inertia of motion. When a bus suddenly stops, a passenger sitting in it, they are tends to fall in the forward direction. Why means when the bus suddenly stops, the lower part of this our body is come to rest, isn't it? Along with the bus, but the upper part of this body is continuous in the same state of motion. We cannot able to change the state immediately. That's why we are falling in the forward direction. This is due to inertia of motion. Next one is inertia of direction. The inability of a body to change the state of direction by itself is called inertia of direction. If a body is moving in one particular direction, it cannot able to change its direction by itself is called inertia of direction. For example, while motion, when the car taking a sharp turn toward one direction, either left side or right side, okay, the persons, those who are sitting in the car, will lean in one direction. Okay, if the car is taking a sharp turn towards the left side, the passenger will turn in the opposite direction. Okay, that is in the right side direction. Okay, this is due to inertia of direction. Now we can see some examples of inertia. When you shake the branches of a tree, some leaves and fruits will detach from the tree. This is due to inertia of rest. And also experiencing a jerk when lift suddenly starts to move. When the lift suddenly starts to move, we will experience certain jerk. Okay. Then when an athlete runs some distance before jumping, this is help him to move or jump higher and longer. Okay. These are the examples of inertia. Now is the time to do your worksheet. Okay. Dear students, you have to learn and write these definitions in your notes. Okay. First question, define velocity. Second question, define speed. Third question, define acceleration. Next one, define inertia. The last question, what are the types of inertia? Okay, learn and write in your note. Okay, thank you students.